Hey there, space enthusiasts. I'm Shuja and welcome. Ever gaze up at that brilliant orb in our sky and wonder about its true nature, its sheer power, its incredible journey through the cosmos? The sun, our sun, is more than just a source of light and warmth. It's a dynamic, turbulent, life-giving celestial furnace, a star among billions, yet uniquely vital to us. It dictates our days, fuels our planet, and holds our entire solar system in its gravitational embrace. Its story is one of unimaginable energies, vast timescales, and profound connections to everything we know. Today we embark on a journey, a voyage of discovery to explore the very heart of our solar system. We're going to peel back the layers of this familiar celestial neighbor and reveal the extraordinary secrets it holds. From its fiery core to its far-reaching influence, the sun is a testament to the grandeur of the universe. It's a story written in light, heat, and gravity, a story that's still unfolding, so prepare to be amazed. Ever wondered what makes our sun so special? It's not just another point of light in the night sky, it's our cosmic anchor, our life-sustaining powerhouse. Its brilliance can be blinding, its heat palpable even from 93 million miles away. But beyond these everyday experiences lies a realm of extreme physics and mind-boggling phenomena. Stick around as we dive into 10 mind-blowing facts about the sun that will leave you starstruck and perhaps give you a new appreciation for that star we so often take for granted. Let's begin with a fundamental truth, one that connects us to the vast expanse of the cosmos. Our sun is a star. It's not a planet, not a solid body like Earth, but an immense, incandescent ball of gas, a seething sphere of plasma. Imagine a celestial entity so massive that its own gravity crushes its core, igniting the very elements it's made of. The sun is primarily composed of hydrogen, about 74% of its mass, and helium, around 24%. These are the two simplest and most abundant elements in the universe, the primordial building blocks forged in the aftermath of the Big Bang. Within its core, a process of unimaginable power takes place, nuclear fusion. Under colossal pressure and at temperatures soaring to millions of degrees, hydrogen atoms are fused together to form helium. This transformation doesn't just change one element into another, it releases a tremendous amount of energy in the form of light and heat. This is the energy that bathes our solar system, the energy that makes life on Earth possible. Our sun is just one of hundreds of billions of stars in our Milky Way galaxy, each a similar furnace, each with its own potential story, its own possible retinue of planets. It's a G-type main sequence star, often colloquially and somewhat inaccurately called a yellow dwarf. Journey with me now, deep into the heart of our star, to a place of almost unimaginable conditions, the sun's core. This is the engine room, the crucible where the sun's energy is born. Here, the temperatures are truly staggering, reaching up to an estimated 15 million degrees Celsius, or about 27 million degrees Fahrenheit. To put that into perspective, the hottest lava on Earth barely reaches 1200 degrees Celsius. The surface of the sun, which we see as the brilliant disk, is a cool 5500 degrees Celsius by comparison. The core is a different beast entirely. The immense pressure in the core, over 200 billion times Earth's atmospheric pressure, crams hydrogen atoms so tightly together that they overcome their natural repulsion and fuse. This is where the magic happens, the thermonuclear reactions that convert mass into energy, as described by Einstein's famous equation E=mc2. Every second, the sun converts about 600 million tons of hydrogen into helium, releasing an amount of energy equivalent to billions of hydrogen bombs. It's this relentless, furious activity in the core that has powered the sun for billions of years and will continue to do so for billions more. It's a place we can never visit, only comprehend through the language of physics. But the sun doesn't just feel immense because it's the brightest object in our sky. It truly is a behemoth, a titan on a scale that dwarfs our home planet. Imagine Earth with all its mountains, oceans, and continents. Now try to picture fitting approximately 1.3 million Earths inside the sun. That's right, if the sun were a hollow ball, you could pack over 1 million planets the size of ours within its volume with room to spare. Its diameter is about 1.4 million kilometers, or roughly 870,000 miles. That's about 109 times the diameter of Earth. Think of it this way. If you could line up Earth side by side, you'd need 109 of them just to span the Sun's diameter. And in terms of mass, the Sun accounts for an astonishing 99.86% of the total mass of our entire solar system. All the planets, Jupiter, Saturn, Uranus, Neptune, Earth, Venus, Mars, Mercury, along with all the asteroids, comets, and dust, make up a mere 0.14% of the solar system's mass. Our star is the undisputed heavyweight champion, its gravitational influence shaping the orbits and destinies of everything that circles it. This sheer size is what allows it to maintain the gravitational grip necessary to hold its family of planets together. Chapter 4, Fact 4, Cosmic Commute. Sunlight's 8-minute journey. Consider the light that warms your face on a sunny day. That light, that energy, has undertaken an incredible journey to reach you. It doesn't arrive instantaneously. Light, though the fastest thing in the universe, still takes time to travel across the vast cosmic distances. The Sun is, on average, about 150 million kilometers, or 93 million miles, away from Earth. Light travels at an astonishing speed of roughly 299,792 kilometers per second, about 186,282 miles per second. So do the math and you'll find that it takes sunlight approximately 8 minutes and 20 seconds to travel from the Sun's surface to our planet. This means that when you look at the Sun, safely of course, never directly, you're seeing it as it was over 8 minutes ago. If the Sun were to suddenly, magically vanish, we wouldn't know about it for more than 8 minutes. This delay is a fundamental consequence of the finite speed of light, a concept central to Einstein's theory of relativity. It's a constant reminder that we are always observing the universe as it was in the past. This distance, by the way, is so significant that astronomers use it as a unit of measurement called the astronomical unit AU. So Earth is 1 AU from the Sun. Chapter 5. Fact 5. The Sun's powerful and turbulent magnetic field. Our Sun is not just a serene ball of light, it's a magnetically active star possessing a powerful and incredibly complex magnetic field. This field is generated by the movement of electrically charged particles, the plasma within its convective zone, a sort of boiling motion of hot gas rising and cool gas sinking. Because the Sun rotates differentially, meaning its equator spins faster than its poles, these magnetic field lines become twisted and tangled over time like a giant cosmic rubber band ball. This tangling stores enormous amounts of energy. When these tangled magnetic field lines suddenly snap and reconfigure, they can release vast quantities of energy in spectacular events known as solar flares and coronal mass ejections, CMEs. Solar flares are intense bursts of radiation, while CMEs are massive eruptions of plasma and magnetic fields hurled into space. These phenomena can create sunspots, which are temporary, cooler, darker patches on the Sun's surface where magnetic activity is concentrated. These magnetic storms can have significant effects, even here on Earth, influencing our satellites, power grids, and creating the beautiful auroras. The Sun's magnetic field is a dynamic and ever-changing feature, driving much of its visible activity. Chapter 6, Fact 6. A middle-aged star. The Sun's 4.6 billion year history. Our Sun, like all stars, has a life cycle, a birth, a long period of stability, and an eventual demise. And right now, our Sun is in its comfortable middle age. Astronomers estimate that the Sun is approximately 4.6 billion years old. It formed from a vast rotating cloud of gas and dust known as a solar nebula. Gravity caused this nebula to collapse, and as it did, most of the material gathered in the center, becoming hotter and denser, eventually igniting to form the Sun. The remaining material flattened into a protoplanetary disk from which the planets, asteroids, and comets of our solar system were born. For nearly 5 billion years, the Sun has been steadily fusing hydrogen into helium in its core, providing the consistent energy output that has allowed life to evolve on Earth. It's currently in what's called its main sequence phase, a period of stability that will last for several billion more years. Understanding the Sun's age helps us place our solar system and indeed ourselves within the grand cosmic timeline. We are the beneficiaries of a star that has been shining reliably for eons. a testament to the slow, majestic processes that govern the universe. It's a long and stable period, for which we should be grateful. Fact 7. The Sun's fiery future, becoming a red giant. While our Sun is currently a stable, life-giving star, it won't remain so forever. Like all stars, it has a finite supply of fuel. In about 5 billion years, the Sun will exhaust the hydrogen fuel in its core. When this happens, the core will begin to contract and heat up, while the outer layers of the Sun will expand dramatically. It will swell into what astronomers call a red giant. Its outer atmosphere will bloat outwards, potentially engulfing the orbits of Mercury, Venus, and possibly even Earth. Our familiar yellow star will become a colossal reddish behemoth. During this red giant phase, the Sun's surface will cool, hence the reddish color, but its overall luminosity will increase tremendously. Life as we know it on Earth would certainly not survive these changes. After this phase, the Sun will shed its outer layers, creating a beautiful glowing shell of gas called a planetary nebula. Left behind will be the incredibly dense, hot core of the former star, a white dwarf. This white dwarf will slowly cool and fade over trillions of years, eventually becoming a cold, dark black dwarf. This is the ultimate fate of stars like our Sun, a cosmic ballet of transformation played out over billions of years. We've talked about the Sun's light and heat, but there's another equally crucial force it exerts: gravity. The Sun's immense mass, as we discussed, creates an incredibly powerful gravitational field that extends far out into space, encompassing all the planets, moons, asteroids, and comets of our solar system. It is this gravitational pull that acts as the cosmic glue, holding the entire solar system together and dictating the elegant, predictable orbits of the planets. Without the Sun's gravity, the planets would simply fly off into the cold, dark emptiness of interstellar space. Imagine the planets as dancers in a grand celestial ballet, with the Sun as the choreographer, its gravity dictating every move. Each planet, from swift Mercury to distant Neptune, follows an elliptical path around the Sun, a path determined by the balance between its forward momentum and the Sun's inward gravitational pull. This gravitational influence doesn't just keep planets in orbit, it also shapes their environments, influences their tides in conjunction with moons, and has played a crucial role in the formation and evolution of the solar system itself. It's a constant, invisible force, yet it is the very architecture of our cosmic neighborhood. Beyond the light and heat, the Sun constantly emits a stream of charged particles, mostly electrons and protons, that flows outwards into the solar system. This is known as the solar wind. It's a continuous outflow of plasma from the Sun's upper atmosphere, the corona, traveling at speeds that can range from 300 to 800 kilometers per second, sometimes even faster during solar events. This wind permeates the entire solar system, creating a vast bubble around our Sun called the heliosphere, which extends far beyond the orbit of Pluto. The solar wind has tangible effects throughout the solar system. It shapes the magnetospheres of planets, including Earth's, which deflects most of these charged particles, protecting us. When some of these particles do penetrate our magnetic shield, particularly near the poles, they interact with atoms in our upper atmosphere, causing them to glow. This is the beautiful phenomenon we know as the auroras, the northern and southern lights. The solar wind also erodes the surfaces of airless bodies like the Moon and Mercury over eons, and it's responsible for pushing the tails of comets away from the Sun. It's a constant reminder of the Sun's active presence and its far-reaching influence. Finally, and perhaps most profoundly for us, the Sun is absolutely essential for life on Earth. Its light provides the energy that powers photosynthesis in plants, algae, and some bacteria. This process forms the very base of most food chains on our planet, converting sunlight into chemical energy and producing the oxygen we breathe. Without the Sun, photosynthesis would cease and the intricate web of life as we know it would collapse. It's the ultimate source of almost all energy on our planet. Beyond fueling life, the Sun drives Earth's climate and weather systems. The uneven heating of Earth's surface by the Sun creates atmospheric and oceanic currents, generates winds, and powers the water cycle. It dictates our seasons, our temperatures, and the very habitability of our world. From the warmth that allows liquid water to exist on our surface, a key ingredient for life, to the light that guides migrating birds, the sun's influence is woven into the fabric of our existence. It is our life giver, our sustainer, a constant, benevolent presence in our sky that makes Earth a vibrant, living planet. And there you have it. 10 mind-blowing facts about our very own star, the Sun. From its fiery birth in a cosmic nebula to its future as a red giant, from the incredible heat of its core to the life-giving light it bestows upon Earth, the Sun is a truly remarkable celestial object. It's a constant reminder of the immense scale and power of the universe and our intimate connection to it. Every ray of sunshine carries with it stories of nuclear fusion, vast distances, and the fundamental forces that shape the cosmos. I hope this journey has deepened your appreciation for this stellar powerhouse we orbit. The Sun is more than just a bright light. It's the heart of our solar system, the engine of life, and a window into the workings of stars throughout the universe. Its study continues to reveal new wonders, helping us understand not only our own cosmic neighborhood, but also the potential for life and stellar evolution elsewhere. It's a story of energy, of gravity, of time, and ultimately of us. Thanks for watching. If you enjoyed these stellar facts and this cosmic voyage, don't forget to like this video. Subscribe to the channel for more journeys through the universe and hit that bell icon so you never miss out on our next exploration. Keep looking up, keep questioning, and keep exploring. See you next time, Space Explorers.